The purpose of this video is to go over number 11 on 2.5. The book says to evaluate the end behavior of a function that is in the form p of x over q of x, you're going to look at the denominator, take the highest power of x in the denominator, and divide the numerator and denominator by that power of x. In this case, the power of x is the square root of x. So the limit as x goes to infinity, I would have 15 minus x divided by the square root of x, divided by the square root of 4x plus 4, and since I'm dividing by the square root of x, I'm just going to pull that into what's going there. So the limit as x goes to infinity would be 15 over square root of x minus, here I have x divided by square root of x, and really that's x to the first power divided by x to the 1/2, so that's really x to the first power minus 1/2, which would be left x to the first power, which would be the square root of x here in the numerator, divided by the square root of 4 plus 4 over x. And if I let x goes to infinity, this term goes to 0, and this term goes to 0. However, this term goes to minus infinity over here the square root of 4, which would be 2. So my answer is something that's going to minus infinity divided by 2. Something that's going to minus infinity divided by 2 still goes to minus infinity. So here the answer is not minus 1/2, it's minus infinity. So hopefully that helps you see the key here is when you take x divided by square root of x, that is the square root of x. And then when I plug infinity, the square root of something going to infinity still goes to infinity, and I have a negative out front there. Please let me know if you have any other questions.